Number 1. The diagram shows the tracks from an event at point P in a bubble chamber. There is an uniform magnetic field directed into the page. So this is a bubble chamber. Let me add a photo with this. A proton-antiproton pair with equal kinetic energies. So part A, the curvature is perpendicular to the magnetic field. This can be shown as the curvature shows the direction of the force that the proton and the antiproton experiences and the direction the particles are going. So the direction of force or movement of the particle will always have a component which is perpendicular to the direction of the magnetic field. Always there will be a component. So A is correct. In this way A will not be the answer. Part B, the track curve in different directions. We can also prove this because as there is a proton and an antiproton, the proton will have a positive charge and the antiproton would have a negative charge. As they have opposite charges, their direction will be opposite as well. Part C, the tracks have different curvatures. So this is not a reason for the production of an proton and antiproton, since they have same kinetic energies as it is stated in the question. They have the same kinetic energies, and as it is a proton and an antiproton, their mass should also be the same. So due to this, their radius would also be the same. So C is the answer. Let us check the part D. There is no tracks before point P. So there should not be a track before point P, since so at point P, after an event, there is a production of the proton and antiproton particles. So that event is most probably an explosion which caused the two particles to separate and go in their own directions. So this is also true. The table compares the mass and charge of an electron with the mass and charge of a positron. Select the line in the table that is correct. So this is an electron and this is a positron. These two will have same masses but different charge. This is a negative charge with charge of -1 and +1. So the answer is mass would be equal and the type of charge would be opposite. So the answer is B. Number 3. Which of the following is a correct statement about uniform electric fields? A. The field strength is the same at all points. This is the answer. Since, for example, we have a positive charged plate here and a negative charged plate here, so the field lines would be like this. They will go from positive to negative, having the same gap in between. Same gap. This suggests that the field strength is the same at all points since they are equidistant from each other. Part B, the field strength is the same in all directions. No, the field strength is not same in all the directions. For example, let us take the force that is acting on a current carrying conductor, F equals to BIL sine theta. So for example, this is our wire and this is our magnetic field. So this is the value theta. So here, as the angle between the magnetic field and the wire changes, the value of F for the electric field strength would also change. It will only depend on the component of the magnetic field which is perpendicular to the electric field. So when the angle is 90 degrees, for example this, there will be maximum force since the value of sine theta is maximum when it is 90. We can show this by a sine theta diagram. So we have a graph, x-axis theta and y-axis the value of sine theta. The graph looks like this. So value of sine theta is maximum when the value of theta is 90. So this proves that in part B, this is not correct. The field strength is not the same in all directions. It depends on the angle between the magnetic field and the current carrying conductor. Part C, the field produces no force on a stationary charged particle. This is not correct. The field produces force on a stationary charged particle. Number 4, in an electron gun, electrons are released from a heated filament. What is the process called? This process is called harmonic emission. Very repetitive, pretty repetitive. We get it almost every year. So the harmonic emission is when the filament has such high temperatures that the electrons have enough energy to be released from the surface of the metal. So the answer is D. Number 5. The diagram shows two horizontal parallel plates separated by a distance d. There is a potential difference V across the plates. An oil drop with charge Q is held stationary between the plates. Which of the following gives the mass of the oil drop? So since it is stationary, there are no resultant force acting on the point Q. So for example, we can say that a force of mg, the weight is acting downwards, and since it is in an electric field and it is a charged oil drop, so a force is acting upwards of EQ since F equals to EQ. So EQ and mg are balancing itself. So we can write EQ equals to mg. We also know the formula V equals to ED. So E will be equals to V by D. So we can replace that E here. So the answer matches with part B. So the answer is B. Number 6. Which of the following is an equivalent unit to the Tesla? So the Tesla is the magnetic flux density, which is denoted by B. We also know the formula F equals to BIL. So we just have to make B the subject. So the units will be for force. Force is Newton, current is ampere, and the length is meter. So the answer is D. 7. A magnetic field of flux density 4.0 into 10 to the power minus 3 Tesla passes through a coil of wire at an angle 55 degree to the plane of coil. The coil has an area 2.5 into 10 to the power minus 3 meter square. Calculate the magnetic flux through the coil. So we have magnetic flux equals to magnetic flux density into area sine theta. This sine theta is here since we use the sine of this theta value to determine the vertical component of the magnetic field through the coil. So we have magnetic flux density, which is 410 into 10 to the power minus 3 into 2.5 into 10 to the power minus 3 meter square, which is the area into sine theta. So the value of theta is 55. So the answer of magnetic flux is 8.2 into 10 to the power minus Weber. So the answer is B. Number 8. A proton accelerates in an electric field and gains kinetic energy, giving it a change in momentum del P. An alpha particle accelerates in the same electric field and gains the same kinetic energy. The magnitude of the change in momentum of the alpha particle is given by. So we have to determine the change in momentum of the alpha particle with respect to the change in momentum of the proton. So we know that K equals to P square by 2m. So let's assume this is for the proton. So the momentum would be root over 2m into K. This is for the proton. The momentum of proton is this. We also know that the alpha particle has a nuclear number of 4 and proton number of 2. So the mass would be 4 times that of the proton. So if we consider that the momentum is equals to 2 into mass into K, this mass would be 4 times that of the proton. So the momentum of the alpha particle momentum would be 2 into 4m into K. We can write this as 2 into 2 square m into K. We can take this 2 square outside, so 2 root over 2m K. So we will now realize that this part and this part are the same. So we can just put P here. So it would be 2P. So the answer is B. A 4.0 μF capacitor discharges through a 560 kilo ohm resistor. What is the time constant of the circuit? So we have time constant T equals to RC. We have resistance here. We have capacitance here. So we will multiply those. So the answer will be 2.24 seconds, which is answer C. 2.2 into 10 to the power 0. We know that 10 to the power 0 is equal to 1. So C is the answer. Number 10. A proton enters a magnetic field. It has velocity v perpendicular to the field. So there will be a force being exerted on the proton. The diagram shows the path taken by the proton magnetic field into the plane of phase. An alpha particle enters the magnetic field at the same point as the proton, also with velocity v. So it's the same velocity. At which point A, B, C, D, the alpha particle is most likely to leave the magnetic field. So we have to consider the mass to charge ratio. So we know that the proton has a charge of +1 and a mass number of +1. And an alpha particle has a charge of +2 and a mass number of 4. This is the mass number and this is the charge. So the mass to charge ratio of proton is 1. Since the mass is 1 and the charge is 1, so 1 divided by 1 is 1. But for the mass by charge ratio of an alpha particle is 4:2. Since this is the mass and this is the charge, so it would be 2. So this means that since the mass to charge ratio is smaller, it would get deflected but with a smaller amount. So this would go like this and go to a smaller amount C. So the answer would be C.